So we're going to look at how loans work. To do that, I highly recommend you check out the spreadsheet I shared. If you're looking at this in the future, it's in the link in the description of the video. And I got a whole bunch of tabs here. So let's zoom out on this for a sec. And I already pre-built ones, and I have a tab for every kind of problem in the book, in the homework and in the book. So simple interest there, basic compound interest, present value of compound interest, savings annuity, calculating from a payment, what are we going to end up with, savings annuity, what we want, and how to get the payment. What we're going to go over today is how loan payments work, which is also how retirement funds work when you start withdrawing money. Turns out it's exactly the same idea, just a different perspective. You're getting the money instead of the bank. Payout annuity is just the reverse of that same loan idea. An amortization table, this is what I'm going to go over with you now. So I'm going to show you how to build this table right here. So I'm going to add a new tab and just start from scratch. So some things I'm just going to put in the top to keep track of. I need to know the loan amount. I need to know the annual percentage rate. Let me blow this up again. Good. I need to know the compounding period. And what else do I need to know? I need to know the years that go by. And based on all of that, I can calculate a payment. I'll get to that in just a minute. But before I do that, I'm just going to show how the bank reconciles this. So I'm going to keep track of a couple of things here. I'm going to keep track of the period, which is like I start off at 0 with what I owe, and then 1 month later, 2 months later, and so on. And then I want to keep track of what I'm paying in. I want to keep track of the interest amount. And again, the way it works is whether this is a credit card or a loan, you send the bank a payment, they first take out the interest you owe them, and anything left goes to reduce your balance. So I'm going to add another column here for the balance reduction. And then the final column is going to be whatever the current balance is. Cool spreadsheet trick. If you double click on the edge of the column headings D and E there, it will look at everything in that column and make it just wide enough to see it, which is kind of cool. So that expanded it. If I do it over here, it'll make that column a little narrower. Which is kind of all right. So my loan amount I said is going to be $30,000. Let's make that money. My APR is going to be 5%. I'm going to have monthly payments, and I'm going to do this over 5 years. And I'll show how to calculate the payment in a minute, but for now, I'm just going to make up at $600. I have no idea if that's even close to right. Saying, hey, I can afford $600. Let's see what happens with that 30,000. My balance here, I'm just going to go equals and grab that number because that's my current balance. I don't want to fill that down. The payment is always going to be grabbed from there. So here, I'm just going to go equals that cell. And I always want to use that amount. So when I fill this down, I'm just going to say always pull from cell E2. And to do that, I just put a little $ between the E and the 2. And that says when I copy this down, don't mess with the 2. Okay. I don't have to worry about the E because I'm just copying it straight down. It's not going to change the E if I copy it straight down. All right, and so it says it wants to fill it, and yeah, sure, you can fill it. Oh, I hit the wrong button. Interest amount, that's just simple interest. So simple interest here is just equals. Now the interest is always going to be based on the previous balance. So a month went by with that balance. So I'm just going to click on that number right there, not the one up top, the current balance, because that's going to change here in this column. And then I just multiply that by the interest rate, which is here. And then I adjust it for the monthly. And so I'm just going to then divide that by the 12 here. Now, when I fill this formula down, the balance is going to be new each time. So every new row in E is going to be my new current balance. So I do want the E4 to change. So I'm going to leave that the way it was. The B2 says, look there for the interest rate. That's the only place the interest rate lives. So I got to fix that 2 with a $sign. The period's 12, that's always right there. It doesn't change. Oops. So I want to fix that 2 with a dollar sign. If I don't do those fixes, then when I fill this formula down, it won't work right. So I just need to tell the spreadsheet what changes, what doesn't. All right, enter. I don't need to fill it down yet. Balance reduction. That's pretty straightforward. The bank gets my 600 bucks. They say, whoa, you owe me this much first, then we'll worry about your loan amount. And so this would be what's left to reduce that. So then there I just go equals, take the previous balance and subtract this. And the bank just does that every month. They just repeat the same calculation when I send them a payment. So basically what I can do now is just highlight that row of formulas. And again, I needed a dollar sign on this one because I'm always saying that's my payment. Look there for the payment. So that formula is good. This one, I'm getting a changing balance, but I always have the same interest rate and it's always monthly. So I had dollar signs there. This one didn't require dollar signs because it's always grabbing whatever this payment is and whatever that interest amount is. Now the payment is the same, but it doesn't have to be, right? You can, most mortgages, loans, you can pay more if you want to. So it's possible I'm going to pay more than 600. So that's leaving me open to that. Have a variable payment, always to the left. And then this one right here says always grab the previous balance and subtract the balance reduction to the left. So I don't need any more dollar signs. And then I can just fill this down and it should just work. Now, how far is this? Eventually, okay, you see I got negative numbers here. So at 600, let's delete some of these. Whatever period this is, now it says 61, that's the 61st row, but I have some extra stuff. So I need to figure out how many months it took. So I need to copy the 1 and the 2, highlight them, then get the autofill button, drag it down. See how many months that is. It looks like it's going to be 50 something months. So my $600 guess wasn't that bad. 12 times 5 is 60. 5 years later. So I was close at $600. Wow, I got lucky. And so this says if I pay them $600 in that last month, that's an overpayment. And so I can adjust that and figure out what to actually pay. I owe them $100 really plus 46 cents. That should be my final payment there. So if I just adjust this right here and say, let's just grab that last number there and then add on the new interest amount, then I should zero out the account perfectly, which is kind of sweet. All right, I'm gonna fill that down just a little more just for fun and then just talk about a couple more things. And I'm gonna go into the negatives just for fun here. Now, they're gonna make a calculation that's gonna give me the exact payment. We'll look up that formula in a second. But I could do whatever I want. Like I could say, well, I don't know if I can pay 600. I think I'd rather pay 500. And I can just type 500 there into the spreadsheet and the spreadsheet's going to auto calculate everything else. And then I can kind of scroll down and see, all right, where does $500 a month put me? Over here, I finally go from positive to negative. So that's going to take 70 months. So that would be 5 years plus 10 more months, almost 6 years to pay off the car at $500 for $30,000 at 5%. And again, how did I make this spreadsheet? I really only used the idea of simple interest and some subtractions to figure out how the loan's going to work. I didn't do any fancy math here at all. I guess adding the dollar signs was kind of fancy, but really this is just simple interest repeated. And I mentioned before, that's what compound interest is, and that's what annuities are too, in their heart, in their core. Now, what we really want to calculate here is what's called an amortization payment. And that is the amount that will perfectly zero out the account at the appropriate time, right? And what I can see here, it's a little less than 600, because when I put 600 in, I ended up, at 57 months is where I was going to have paid more than enough to zero out the loan. So let's make that calculation. Now, reminder, on the home page in this week for finance, I summarized all the formulas in the book that you need to know in this table right here. So which one do I want? Well, I want the formula that calculates a payment for a loan, and that is one of these last two ones. The payout annuity / loan here, what that does is, given the payment, the D calculates what the loan amount should be. Or if this is like a retirement fund paying out, it's the amount you start with. And it turns out a loan and a payout retirement fund are exactly the same math. We want which is called a payout withdrawal or the amortization payment. This calculates the payment here. And notice it looks a lot like the savings annuity one. Blow that up a bit. The savings annuity payment has the 1 plus R over K to the NK minus 1. And the reverse problem just reverses that. We switch the -1 to the front and we make the power negative. That's the only change. Most common mistake people make when they use this formula is they forget that negative power right there. So we're going to apply this formula right here. So let's give it a shot. I am going to, oh, and there's also the spreadsheet version, and the payment is just called PMT. So we could use that too. So I'm going to try the spreadsheet version, and then I'll try this other version and see what happens. I'm going to do that one first. I'm going to delete this, and I'm going to zoom out just a little bit so that I can see the prompts it gives me. So I'm going to type equals PMT, and the computer says, hey, I know PMT. It's the periodic payment for an annual investment. Turns out it's also the periodic payment for a loan. So I'm going to just click that, click this, and they say, okay, what's your rate? Well, like before, that's got to be the periodic rate. So not only do I have to tell it the 5%, but I got to say it's 5 over 12 because months are my periods here. So that's a lot like what we did before with the annuity. Number of periods, that's our exponent, the months times the years. So then I just click on my months and then multiply by my years, comma. Now it wants to know what the present value is, and double check my formula here. My present value, and again, we get that weird negative thing. It's the negative of what the amount is, okay? So then I'm going to put a negative, that little dash there, and then I'm going to click on the loan amount there, comma. What's the future amount going to be? 0 is what I'd like it to be. And then whether I pay at the beginning or the end, I'm just going to ignore that, close the parentheses. And this says your payment should be $566.14. And remember, I set up my spreadsheet to always pull the payment from that cell there. So now I can see that. And what I should see, if I go down to the 60th month, I should have a perfect 0 balance. See what happened. Boom, nailed that sucker. It zeroed it out. So now I just did some complicated math. This formula right here is not trivial. The spreadsheet formula, I like it's a little cleaner. I like using that one. I'm going to type this one next, both in my spreadsheet and in my scientific calculator. So I want to screenshot this and attempt to fill it in on paper, and then I'll plug it into the calculators. So let's add this to a new page. Load that up a bit. All right, so here's what we know. We know that the starting amount, that's my loan amount, they're calling that P0, that's that $30,000. We know our R as a decimal of 5%, 5 hundredths. We're doing K equals monthly, that's a K, not 12. And our capital N, our years, we're just going for a 5-year loan for this car amount right there. So let's try it. So our payment, D, big fraction, is going to be the 30,000 times 5% as a decimal over 12, divide by, and the spreadsheet definitely needs those parentheses. Some calculators don't. This next parenthesis is essential. 1 plus 5% over 12. Next parentheses, most calculators need to. And don't forget, I mess this up all the time. It's got to be a negative up there. 12 times 5, which could also be 5 times 12. I wrote it backwards up there. All right, I think I got it. Okay, that's what I want my calculator to do. So now I'm going to try that. So I'm going to do Desmos first, then the spreadsheet. Let's see, where's my Desmos? There you are. All right, so 30,000. fraction first, 30,123 times parentheses, 5% over 12, those parentheses in the right spot. Denominator, parentheses, 1 minus this time, and then that compound interest base, 1 plus our 5% over 12 months, raised to the power, parentheses, don't forget the parentheses, now it's negative because it's a loan, the power is negative. Same thing if I'm doing a payout on a savings account, a retirement account, and I want my 12 times 5 here. And I should get the same thing that PMT formula gave me, $516.14 rounded. All right, do that one more time. Use that formula to double check this right here. So that was the PMT formula. I'm going to try it here using the other one. So on this one right here, it's pretty much going to happen the same way I did it in Desmos. It's just going to look a little different. 30,000, click on it, times parentheses, then click on your R, divide, click on your K, close. Slash for the denominator, parentheses, 1 minus, parentheses, 1 plus, R over K, close that, raise it to the power, which is our little caret, parentheses, and then it is K times N here. What's up, Robert?
You forgot the minus.
The minus only, oh yeah, thank you. Only goes in the exponent right there. All right. And then hit enter, and then I'll blow that up so you can see it better. I don't know if that was big enough. I got the same amount, 566.14. So it looks a little funkier, but I'm just following what I wrote on my paper exactly. The big difference is instead of this big butt fraction bar here, I just have that little slash and then the second parentheses is the only difference. That was exciting. And again, this is in that shared spreadsheet. So now this is set up where if you just plug in your numbers here, it does everything for you. Now, caveat on that, this one is only set for 5 years. If somebody says they want to buy a house for 300,000 and they can get an interest rate of, let's say, 6.5%, houses are usually for more than 5 years. The house loans are like 20 or 30 years. So let's say it's 30 years. So this tells me here for if you borrow $300,000 for a house, that's 7%. And you might say it's 300,000. That's a ridiculously large amount. Well, last year, the average house price in Pendleton, Hermiston area was actually pretty close to $300,000. It was like, I don't know, 280,000, I think, is what I calculated when I surveyed the market. It's starting to drop a little. So maybe you get lucky and you find a decent house for, 250. If you go for a really small house, like maybe 1,000 square feet, you might get lucky and be able to find a $180,000 house. 7% interest, kind of common rate around now, I think. So your payment would be 113,000. Now, keep in mind, my table at first works perfect, but 12 times 30, how many months is that? Let's do that here. Months. Oops, that's supposed to say months. There we go. Equals 12 times 30, 360 months. So for this spreadsheet to continue to track my house loan, I would have to go beyond the 5 years here. And I went a little bit beyond, but not to 360. But I could easily do that by just grabbing the last 2 rows and just filling them down. Almost there. Oh, somewhere in here. All right, there it is. 360 months later, we zeroed out that account. And that's how car loans work. That's how home loans work. And if this was a credit card balance, this is how a credit card balance would work if you didn't buy anything else on that credit card. So like in my youth, I got my first credit card when I was in college and I accidentally spent $1,000 and I'm like, oh shit, I got to pay for that now. Suppose I wanted to pay that off and my credit card Credit cards they're typically higher. Maybe my credit card's like 14.5%. And let's say I want to pay that off in 1 year. $1,000 at 14.5% over 1 year means I would have to pay about $90 a month to zero out that account in 1 year. So I can analyze all kinds of things, loans, credit card balances, with a fixed payment or not. I can plug in any payment I want here and override what it already does. So I think this is a powerful tool. It's interesting.